Hello, welcome to the notes today on linear equations y equals mx. We have seen this formula before, but we're going to be diving a little bit deeper into it today. So just to remind you, a graph shows proportional relationship if it is a straight line that passes through the origin. That is one of the key concepts that we talked about the other day and at the beginning of the year. Also, in a proportional relationship, the constant of proportionality, can be found by using y divided by x. Okay, and sometimes we call again the constant of proportionality the COP. So, our first example says that the graph shows the distance d a car travels in time t at a constant speed r. So they're just reminding us what each of these are. What is the constant speed of the car? So the constant speed is kind of similar to the constant proportionality. So we go to thinking that it's miles per hour. So miles per hour would be 30 miles at 1 hour. So constant speed appears to be 30 miles per hour on kh. How far will the car then travel in 2 hours? Well, that's simple. We look at our graph where 2 is, go to our line, then go to our corresponding y value, and it is 60. Really important here that we do have our labels because 60 can mean so many different things if it doesn't have a unit. C says how long will it take the car to travel 120 miles? Well, now we go to where our miles on the y-axis is and bring our over to our line, and our corresponding x value is 4 hours. Okay, for D, now they're asking us to do our final step here to write an equation in the form of D equals RT to model the situation. And D equals RT, if you compare it to Y equals MX, they do look awfully familiar. Okay, especially since your D is your distance, which is on the y-axis, and the time is your t, which is on the x-axis. They do line up perfectly. So, if we've already figured out what our constant speed is, we can just substitute our rate of 30 miles per hour into the formula and get D equals 30t. So I'm going to ask you to go on to try number 2. This one's very similar to what we just did with number 1. So go ahead and give that one a try. Okay, so what you're looking for here again is what is the constant speed of the train. So how far is the train going every mile, or excuse me, every hour? That would be 100 miles in 1 hour. So then that is our COP, or our unit rate. And so our unit rate goes where the R is here. So next, Next it says here that recall that the graph of a proportional relationship is the line that passes through the origin. An equation that models a proportional relationship, again, can be written in the form of y equals mx. The equation y equals mx shows y is always a constant multiple of x. This is the big kicker for today, that an equation in the form of y equals mx is an example of a linear equation. An equation is a linear equation if the graph of all its solutions is a line. It's always assumed that a line is straight, okay? You wouldn't say that this is a line, that's a curve. So for a linear equation, you're seeing the word line in there. So now on to the back. Number 3 says that a restaurant is running a lunch special. Write an equation that models the lunch price y based on the original price x. So our lunch prices are showing that all prices are 1/3 off. So if the original amount is 1 whole, because that's where we're just going to associate with it, and we're taking 1/3 off, that means I would be subtracting 1/3. That means that the price for what you actually pay would be 2/3 in this scenario. So you're paying 2/3 of the original price. And if the original price is x, in the form of y equals mx, I'm paying 2/3 of x, so I'm just really going to put the 2/3 in place of where the m is. Okay, number 4 again is similar to number 3. Give that one a go. Okay, so again, similarly, I'm saying that I'm starting with the beef is 1 whole, subtracting 1/4 of its weight, means that it's going to be 3/4 of its weight. I'm not saying that the burger is 1 pound to start or anything, I'm just saying that that's 1 whole. So again, 3/4 will then be the constant of proportionality. Question number 5 says that the number of words y you can type in x minutes can be represented by the equation y equals 55x. The number of words your friend can type in x minutes is modeled by the graph. Which of you can type faster? So they're giving us 2 pieces of information. One, about your friend, and they stated that your friend can type, your friend is from the graph. So your friend, I want to figure out how many words per minute that they can type. And if I look at my x-axis here, I notice that I don't have per minute, I don't have 1 minute listed on here. So I'm going to go and find one that crosses perfectly at one of the coordinates. So this one crosses well, this one would cross well, this one would cross well. So you just pick your y-coordinate and the corresponding x-coordinate to it. And I take 150 and divide it by 3, and I'll get that your friend can type 50 words per minute. And if I was to write that as an equation, I could substitute the 50 in place of the n. The information about you said that in the equation, y equals 55x, your constant of proportionality would be the 55. So who can actually type faster? Well, the person that can get through more words, 55 words per minute, that would be you. So you can type faster. So on to our last example, number 6. Again, this one's going to be a try on your own. Okay, so in this scenario, I had an equation and a graph again. The car was y equals 65x with a m of 65 miles per hour, and the train at 75 miles per hour, so which goes faster? The train. Okay, so that was a quick little overview for the notes today. Have a lovely weekend, and we will see you on Monday.